Well, we are just going to keep this train rolling here and talk about pH and pOH and all that stuff. And, why do we say pH neutral is pH 7 and stuff like that? And we're going to use a different calculator than we have in the past because we should learn how to use a variety of calculators. All right, so here's the idea with pH and pOH. If we have neutral water, now tap water is pretty much neutral. Not totally neutral because there's some things in it like dissolved calcium ions and sodium and stuff like that, but it shouldn't be bad for you. It just affects the pH, but we have to learn a little more about pH so we're not worried about water. But okay, so in neutral water, these concentrations, right, remember that's moles per liter, right, the molarity of H plus and the molarity of hydroxide should be equal, okay? But let's make sure we know what's going on in water, okay? If you have a beaker of water, yeah, let's put a little bit of water in there. Here we go, okay? Inside this water, a huge amount, 55.8 moles per liter, is H2O. Like, that almost sounds kind of stupid. Well, hang on. Water, though, tends to self-dissociate just a little bit. You get H plus, right? So water breaks apart. That shouldn't really blow your world out of proportion, right? So water, liquid water here, almost completely 100% water molecules here, but some of them break apart. Okay, so how much do they break apart? Let me give you an idea, okay? This concentration is that number, okay? This is 1 out of 10 million. So maybe that gives you an idea that that's pretty small. 1 out of 10 million parts is an H plus. And it's the same for this guy too, right? They're equal. So if I had to, I guess we could draw it this way, that H2O, right, is this great big huge amount like that, and they're still going back and forth at the same amount, same rate, turns into H pluses and OH minuses, goes back to H2O, goes this way, goes that, same rate, 5 miles an hour, whatever you want to call it, molarity per second. But a wee little bit is H plus, and a wee little bit, in fact, if you wanted to do it, it would be like that. In fact, if it were 1/10 millionth, it would be even smaller than that. In fact, there it is. Gotcha, I didn't draw anything. Okay, but you get the idea that it's incredibly huge amount of H2O, and then these wee littles here, these wee littles that are so small, you can't see them. Okay, that's what's going on. Okay, but that's still important. Okay, you might say, what? Why is 1/10 millionth of something important? It is, and in the body, if this is off by 10 times, right, if this goes to here, you could die, okay? I mean, it's pretty serious stuff. So even though it's really, really, really small numbers, don't focus on this huge number. Focus on these little guys. Makes a huge difference sometimes. Other times it doesn't matter. Other times it doesn't matter, all right? So we actually have a clue now to what's going on with pH values. So here's what happens. Generally, pH is more common than pOH. 85% of the time you're going to deal with pH anyway. You hardly ever see pOH. Why? Because they picked this and it's just more common. Okay? And what we said was when you have neutral water, this is the concentration of hydrogen ion. That's neutral water, right? Why is it neutral? Because it's the same amount as OH minus, okay? So when those two are equal, that's where we're getting neutral, okay? But we saw in the last video that to write these out in conventional ways is just ridiculous. 6 zeros and a 7. And what if that even got smaller and smaller? So what somebody said was, why don't we do this? Why don't we call pH, why don't we just say the pH is actually just the negative log, which is they're saying like it's just a negative exponent of 10. That's all we're saying here. So when you have pH here, you're saying, what's the negative exponent? Well, then the pH would be 7. And we don't have to do this calculation. We basically did it before. Let's take another one, though. The pH is 7. Let's do this. Example 1. What if we took a pH, let's make something a little bit more acidic. All right, so 0, 0, 0. And this time, instead of a 1 here, right, for neutral, let's just make it a little bit more. So we're going to say it's 533 moles per liter. Okay? So it's just a little bit more because, right, what we had for neutral was a 1 here. Okay? But now we're going to make it 5 times the concentration of hydrogen ion. We're going to make 5 times stronger. What happens to the pH? Okay, we know this pH is 7, right? We took the negative log of that number. We got 7. What do we do with this guy? All right, pH equals the negative log of 5.33 times 10 to the negative 7. Okay? Same number, just put it in scientific notation. Get good at that, by the way. All right, let's try it on this calculator. So if I had 6, okay, so you have to put the number in first. So if we took 5.33 exponent negative 7, much easier on this calculator. Ready? We're going to take the log negative 6.27. Okay, so this equals 6.27. Right? That says if I took 10 to the negative 6.27, I would come back to that number. But this is the pH. That's all we're worried about. The pH of that really small number is 6.27. See, when I push the negative sign, I just got rid of this guy here. Because we just don't do that. We don't leave the negative sign in there. It almost doesn't matter. It's just we're looking for this, the 6.27. So that's the basic acidic idea of figuring out pH. All right, so we're going to do a bunch of these together first. All right, and we're going to do them in reverse. I want you to see the formula first. Okay, there's 2 equations or formulas here. pH equals the negative log of hydrogen concentration. Now, if you're not a mathematician, this will help you. If you are a mathematician, you might say, oh, I didn't know that. I can reverse this and say 10 to the negative pH equals my H plus concentration. Memorize these. Okay? Memorize these. You will certainly need these in AP chemistry and any more chemistry you take. Yep, you're gonna have to do. We're gonna do 2 or 3 examples of each. I want you to be comfortable with it. Okay? So here's this idea. What if I had find the pH when H plus equals 0.000286. All right, so pH equals a negative log, negative. That's just a sign changer, basically. This guy, you could leave it this way. I'm going to challenge you a little bit and do that, right? Hopefully you see that that's your logarithm. You're going to be something around 10 to the something with a 4 or a 3 or maybe a 5. Let's see what happens here. Clear? So 2.86. Got the number in there. Take the log right here. Boom. Now, see what it says? 3.54. But just change the sign. That's all the negative thing does. I push this guy right here. Oop, push that guy. Change the sign button. That's all that is. Sometimes they're called CHS. 3.54. This pH is 3.54. We're doing another one. Here we go. Let's take, what if H plus equals 6.07 times 10 to the negative 3. What if we have that? That's the molarity, right? That's the moles per liter of H plus, right? We could write like this, 6.07 and use brackets. You get the idea. So what's the pH? pH means you take the negative log of that number, 0.07 e negative 3, right? You see that in AP Chem, we have you try to do it in your head. This 4 became 3.54. Got a little smaller than 4, right? Actually, you get a little bigger. 3.54. So maybe we should expect this to be about a 2 point something. Let's just guess 2.5, see what happens. All right? Here we go. 6.07. Exponent negative 3. Boom. Take the log. Negative 2.217. 2.217. Now, why did I do that? Well, all I have to do is push the change sign button right there. Watch what happens. Magic. You don't really need to push the button. Just remember, pH is going to be positive. Not always positive, by the way. Okay? That's how you calculate pH. We're going to get you good at that. Right? So, what if we have to go the other way? What is H plus when pH equals? We have some number. We're going to pick, what if the pH is 5.88? Here we go. So, H plus, concentration in moles per liter, equals 10 to the negative 5.88. Right, so let's do that. Clear. This guy here, you barely see him. Right, 10 to the caret. That guy right there, okay? I don't know if we have to put that number in here first. I think we do. Okay, so what did we say the pH was? 5.88. So 5.88. Change the sign. That's negative. Cool. Invert, because I want that guy. So he's green. Invert. 10 to the x. Boom. Okay, now this gets tricky. Some of you might want to convert that to scientific notation, and you can. This calculator will not do that for you. Okay, so we got to figure. Oh, yes, it will. Down here, see that guy? Boom. Okay, so we get this 0.1. Just watch this. Just take this and get them here between 1 and 3. So 1, 2, 3, 4. 10 to the negative 6. Okay? 10 to the negative 6. 1.318 times 10 to the negative 6. Okay? If you want to calculate that on this guy, you just have to push the invert button or whatever it is, that green button up there, which I did, trust me, and boom. Magic. Okay? So there it is, 10 to the negative. Just get comfortable with that. Okay? Let's do another one. pH equals 2.80. Where'd you go? pH equals 2.80. All right, so what's H plus? H plus equals 10 to the negative 2.80. And again, if you know that 10 to the negative 2 gets you at 0.01, and then you have 10 to the negative 3 gets you at 0.001, right? So this is like this, right? You're going to be closer to this guy right here, right? Because you have what? Like 10 to the negative 2, 10 to the negative 2.4, 10 to the negative 2.8, 10 to the negative 3, right? So this guy is somewhere in between these. Somewhere between right? So look at these columns here. You have this situation, and you have that. So somewhere in here we're going to see a number. Let's see what happens. Okay? Boom. Here we go. 2.8 negative. And we want that guy. So we invert 10 to the, boom, 0.00158. Right? 0.00158. So H plus equals 0.00158. Yeah? Or 1.58 times 10 to the negative 3. Right? And so does that fit? You know, 0.00158, 0.00158. Yeah, that gets us there. That's what we're doing. Okay? So we have another set of calculations, though, that we need to do. Let's get a whole new page for that. Okay? And you can see some of that old stuff there. It's really not new stuff, but it turns out that pOH is equal to the negative log of OH minus. How'd they do that? Come on. Just replace OH with H, and there you go. And the OH minus concentration equals 10 to the negative pOH. We don't really need to calculate those. We're going to be wasting your time. Just if they give you hydroxide here, then get pOH and back and forth. Okay, so we should be okay with those. There's one more calculation, though, that's going to be very helpful. Okay? 2 more. Okay? There's 2 more calculations. And then you're going to practice. All right. It turns out if we take pH plus pOH, we get 14. Okay? Now, we can do that later with mathematicians, but just go with this. This is absolutely worth memorize. Okay? Memorizing. Absolutely. pH plus pOH. Just get that in your head. There's another one, and that is that this concentration times this concentration is equal to 1 times 10 to the negative 14. And you kind of saw that before. I have to show you. You don't know that you've seen this, but it turns out that this is for neutral water. Okay? And so what happens is 1 times 10 to the negative 7 times 10 to the negative 7. When you multiply exponents, you actually add them together. That's where the 14 is coming from. Okay? And if this were a negative 5, right, then this would have to be a negative 9. So they just have to equal negative 14 up here. Right? That's what's going on. It's a little tricky, but this guy should be memorized. Let's do 1 or 2 examples, maybe more. It might seem like a long video, but it is absolutely worth your time. All right, let's see where this goes. Find the pH when OH minus equals 4.19 times 10 to the negative 6. Okay? This is a 2-step process. This is why I give you videos, just so you know how to do this. I'm going to show you how to do this. Okay? Find a pH. Well, all you have to do is this. You could say, first, get H plus. You say, how am I going to do that? You go up here. Just do this. Right? You have OH here and this number. You just go find H plus. So you can do that. That's one way. Get H plus first and then turn that into pH. Or here's another route. You could take this OH, calculate pOH first, and then find pH. There's 2 ways to do it. Wait, what are you talking about here? Look at this. If I have OH minus right here, I can get pOH. And then once I have pOH, I can go down here, subtract it from 14. All right, let's just do that. All right, we can do both ways. That's fine. Let's do the one in blue. All right, so if you have OH minus, right? How do I find pOH? Well, pOH is a negative log of OH minus. So it's a negative log of that guy right there. Right, we're doing the blue version here, so let's do that. 4.19 negative 6, right? Take the negative log of that. Boom. Change the sign. Boom. So pOH is 5.378. pOH is 5.378. Boom. But you were asked to find pH. Watch this. These two equal 14. Okay. pH equals 14 minus the pOH equals 14 minus the 5.378. Right? So if I make this negative plus 14, it gives me 8.622. pH equals 8.622. And you have to say it like that, 22. Cool. Let's do this black version here, right? Find the H plus first, and then go for the pH. Either one is fine. Sometimes you have to learn both because it's more convenient sometimes to do that. All right. So how do we find H plus? H plus equals. Let's put a colon here. How do you do that? Well, you have H plus times OH minus, and that equals 10 to the negative 14. Okay? All right? I want H plus alone, so H plus is equal to 1 times 10 to the negative 14 divided by the OH minus. That's all. So, and our OH minus was 4.19 times 10 to the negative 6. Okay? Now, that's going to get a little cluttered. Okay? But let's do it. So we have what? We can put them right next to each other. Okay. 1 exponent 14 negative. Boom. Divided by, you should probably put quantity here just to make sure you don't screw it up. 4.19 exponent 6 negative. Close the quantity equals. Whoa. So what do you do with that? Right? That's some crazy small number, right? You can convert it to scientific notation. There's other ways around it, but scientific notation. Okay? We know there's a 2. Man, there's lots of... There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Just remember that. We know it's 2 times 10 to the negative 9. 2 times something. 2 something times 10 to the negative 9. Okay? I invert it. Boom. I get this. 2.3866. 2.38. Let's call it that. That's a really, really, really small number. That's the H plus. By the way, we're looking for pH, so you take pH equals a negative log. And I'm not going to rewrite that number because I don't have time for that. Okay. But if I take the negative log, just push log, then negative. pH is 8.6. That's to the 0, so don't worry about it. pH equals 8.622. Okay? We should do another couple of examples because this can be tricky. This is totally worth watching for people if you have to do this stuff. Okay? Let's say this. If I have pH equals 5.27, that's acidic, right? Because it's above 7. 7 is neutral. So here's pH, 5.27. Question, what is the hydroxide concentration? You have two steps. You have two alternatives here. Okay, let's do them in two colors, just like we did before. Okay, you could first find H plus and then go to pH. Or you could find pOH and then pH, right? Doesn't matter. Either way is going to be fine. All right, let's do the pink version here first. Find H plus first. So here's pH equals 5.27. Okay? What's the formula to find H plus? H plus equals 10 to the negative 5.27, right? H plus equals 10 to the negative pH. So here we go. Where's our 10? This guy right here. Okay. I think you have to put the number in here first. So 5.27 negative. Invert. Find that guy right there. Boom. There you go. 5.37 times 10 to the negative 6. Let's make sure. Boom. 5.37 times 10 to the negative 6. H plus equals. And we should put molar. That's really what it is. We are not done. We need to convert this to pH. pH equals the negative log of that number. I am not going to rewrite it. If you do this for me, I'm fine. Okay? So what do we do here? Take this, leave the number in your calculator, folks. Don't round it. And okay, so there's log. You see change of sign. It's just going to get rid of that. Boom. So the pH is 5.27. Nope, we didn't want that. I'm sorry. Did that backwards, guys. What we wanted was wait a minute. What did we do here? I screwed up probably. Wait. If we have the pH, I wanted to find the OH concentration. That's right. So I didn't want to do this part up here. No. I didn't want to do that. Let's go through. I screwed up. Here's pH, 5.27. If I want to find the hydroxide concentration, first I find H plus, then I find OH minus. Or I can find pOH and then find OH minus. I'm sorry. Let's act like this never happened, okay? Let's just make sure. All right, so let's make sure we got it. pH equals 5.27, and we want to know what is the hydroxide concentration. Let's do it this way. What if we found pOH first? We know that pH plus pOH equals 14. So now, if we found pOH, that's equal to 14 minus pH. So 14 minus 5.27 equals 8.73. So now we know the pOH. Once we have pOH equals 8.73, we also know this equation. OH minus equals 10 to the negative pOH. So it's 10 to the negative 8.73. Put 8.73 in your calculator. Make it negative. Find 10 to the caret right there. Second function because it's green. Boom. That's a crazy small number. So you have to learn how to convert to scientific notation. On this calculator, it comes out to be 1.86 times 10 to the negative 9. 1.86 times 10 to the negative 9. Okay? Hopefully that's a little smoother for you. I apologize for the error. Let's do it the other way though. If you took 5.27, you can get this. Now let's do it another way. What if we had pH equals 5.27, and instead of doing this part first, let's figure out the hydrogen concentration first. So you could do it this way. H plus equals 10 to the negative pH equals 10 to the negative 5.27. Here's our calculator. 5.27 negative, invert. So now we get 5.37 times 10 to the negative 6. 5.37 times 10 to the negative 6. I wish those numbers weren't so similar, but that's what we got. Okay, so there's the hydrogen concentration, but we want hydroxide. So OH times H plus, you can reverse them, equals 10 to the negative 14. You really have to write these out. Okay? OH minus equals 1 times 10 to the negative 14. We're almost done. We're going to land this plane here. 5 point, put here. Let's just make sure you know that. And so what does that equal? Let's calculate it and be done. Let's land this plane. Okay. 1 exponent 14 negative divided by, I like to put quantity in there. I don't think you have to. 0.37 exponent negative 6, quantity closed. There's that crazy small number. And you get 1.862, just like we did before. 1.86 times 10 to the negative 9. And that's going to be your OH concentration. Okay, guys, let's go back and suffer a little bit more. Okay? We had so many calculations in here, I don't know where we are, okay? So, you have this idea that there's a relationship between pH and pOH, and the question is, why do you have pH 7? That's for neutral water. And we found out that water, abundant in H2Os, but it does dissociate, breaks apart into these little guys here, okay? This is really small parts of water. Is actually like this huge amount of molecules, and it breaks apart into these infinitely small ions, H plus, really, really, really small. Okay, so these are the amounts that you have when you have neutral water. 1/10,000,000th of it is actually H plus. 1/10,000,000th of a mole is OH, but they're equal. It doesn't seem like a big deal, but actually, especially in the body, can make a huge difference. So what we do is we learned from before, pH, right, is actually negative log. Log means exponent. Get used to that. Log and exponent. Exponent and log. So we did some examples here. Okay. But I think we might have done this. Yes. Okay. We have to memorize this equation right here. Okay. These two down here, all of these are very relevant to do. Okay. And I kind of give you the reasons how this works out, but now you have this idea. What if you take pH and you don't try to find H plus? What if you have to find OH? It turns out that there are two pathways. You could find the pOH first and then do this, or you could find the H plus first and do this. You should be good at both ways. Okay? So we showed several examples of how to do that. This one is in blue, right? And then we did the other one in black. And the second one that we did was a little more cluttered, but that's the idea. So get really good. Memorize these guys, or at least have them totally on hand when you get ready to do your calculations. And take your time. These are not always easy.